Hello, this is Ryan, and this is my recording for assignment 3, data science. Okay, so first of all, I imported all the necessary libraries, and then I imported the data for the houses as the training set, and the houses test as the test set. And then I explored the data using the head function to print the first 100 rows of the data. And then I also, first few rows of the data, and then try to use a toString to print all the columns that we have on the horizontal way to make sure that we have the visualization of all the columns name. And then I use the describe function to understand the count, mean, standard deviation, mean, 25 percentile, 50 and 75 percentile for the maximums of the range of the data as well. And then I try to print all the columns to see how many columns do we have, and then how many features that potentially we can select for the model. And I try to use the data type to compare with the descriptions that we have on the website. So after just compared to the descriptions, I realized that the flat frontage and the mass VNR area is not the numeric data type as described. So we change it into the numeric type, and then do similarly for the testing sets as well. So we use the panda function to numeric with the target of the data, the columns, and using chords for the error. And then I try to print all the data type to make sure that in my data set I have in 64 objects and float 64. So we come to the sections of cleaning and handling the missing. So try to know how many is missing shelf using these functions. So is no function to see is there any functions that is no, and then some of them to ensure that all the node is pointed out, and then we know the total numbers of the nodes cells on certain columns, and then we use a sorted value and make it descendant to make the largest number of missing value on the top. And then we see that the lot frontage and the mass VN area is missing 259.8. And I try to fill that with the fill and eight functions, the built-in functions, and using the mean fill at the empty values with the mean of the entire columns. And similarly, we do it to the test sets as well, and also fill it with the mean of the column. And then now we're working with the features. So I try to add the each feature by adding the difference between the year sold and the year built of the house, and then similarly add it to the house tested data as well. And then I drop two of the columns from the data frame. Similarly for the test set as well, so use drop function, and I also added the log price for to ensure the visualizations that will be explained in the next step. And then I gather all the numeric columns into the house numeric data set to have a better visualization, and to analyze the correlationship between these numeric functions and numeric features to the sale price. And I also built a heat map. However, there are many features to visualize, so that's why it's a little difficult to see. So I commented it out, and then we have a correlation matrix right here. And for better visualization, I just selected to print out all the relationship correlations between features and the sale price. So we have like this, and then I decided to sort the value of the top, so we can have the top five of the positive correlations and top five of the graded negative correlation. So we have these as a result, except for the sell price and the block price. And then so we have 10, 10 more significant correlations value, which is listed as these with positive and negative. And then I tried to analyze 10 of the features that I selected using the visualization chart and Scotch as below. And as you can see that most all of the features for the negative functions, they have the negative positive part and to the self rise, like the higher the number is, the higher the price of the house tend to be, and these are the negative function. So the higher the number is, the lower the sell price is. So these are 10 function visualize. And then for the categorical features, I also select them all into a data frame, which is the columns. And then I also try to visualize as well. However, this doesn't visual as well as it should be. So I try to create the dummy data so that we have the base to do the correlations relationship analysis, like the numeric features of which are chained into 0 and 1 for all the type of unique record in the columns. And then after all, I can do similarly to the correlation between these features and the sell price. So we have the top five here, and then another top five here. So these are the entries, like the record the values of the columns. So I have foundation, extra quality, pavement finish type, neighborhood, cell type, and then they have positive correlation, and these tend to have the negative correlation. So this one and this external qualities, they have the same, but just like TA is gonna have negative correlations, and the good tend to have the positive correlation. So we have another 9 more features, and I try to do the value counts for all 9 features to see how many unique record in each column, and I can come up with a chart below, and then I try to visualize these using the means of the sell price, using group by the means of the sell price, and then by each unique function, like each unique features record of these features, and then we can see that there is a pattern that at certain features the price tend to be high, and at certain features the price tend to be low. And then for easier for analysis and building model, I try to do the mapping functions so that we can replace these functions with with the dummy numbers, so that we can do correlations analysis, and then we can put it into the model as the features that we can develop the model function to do predictions for the price. And then so these I also try to check if a value is missing as well. And then as we see that we don't have any missing, and then we come to the model development. So we have 10 features that is numeric, and then 9 features that are categorical, and I decided to select 19 features for these 19 features. And then so I select all the columns in one list, and then I check the NA for the houses using the features columns, and as I see that there's not any NA, not any missing value, and all the data type is in 64 33 32, which is good. And then check for test set. Also, we don't have any missing value, and then before we have like three objects, which is not good, so I decided to turn this object into the int because there's some NA value which make the data type become objects. So I decided to just fill it up and then check it again. So make sure that all are integer, and then I believe that all the data set are ready for use. So we've used the houses with features column for training, and the label is the sale price from the houses data frame, and then how test it is feature columns for the testing frame, and then we will expect to have the sale price predictions as the output. So X identifies as houses with the feature columns that are selected above, and then Y, which is the sale price from the house's data frame, and then X test sets, which is the how test feature columns. And then just for this one, because we don't have the expected label for cross validation, so I decided just to test my model first using the train test splits to split my training set into smaller training sets and in a test set so that I can check how is my model doing, and I build the model linear regression, and then I trained it with X train and each Y train. However, I commented because these were tested, and then I decided to use it with actual X and Y. So we have the model built, and then I try to predict with the X test that I built it here. And after checking the error, I saw that my model is working with 82% of accuracy, which is very good. And then I use it on my actual test set, and then export it into my prediction result, which is this one, which have all of my features, my IDs, and the predictions. However, for submission, I decided to only keep the ID columns and the sale price as requirement, and then I have the submission file, which is this one. So when I submitted, it was 3.39, which is not good. So I decided to use the same concept, same dataset to develop the logistic regressions, and then so these, and then similarly I come up with the data file, which is the logistic file, and then when I submitted model, it was 2.27, which is very good. So I decided to use the regression model for this house market predictions, and thank you for listening.